Hello and welcome. This video is made for the assignment for Engineering Mathematics 1, study code HMS 111S2, and will feature the trigonometric substitution method. We will walk through several steps using this method that can be applied to solve the integration of a rational function. Now we'll start off with the problem, which is to evaluate the integration of x squared over the square root of 16 minus x squared in respect of x by using, of course, the trigonometric substitution method. First off, we'll take a look at the denumerator of the rational fraction. This is useful to determine the a value. Now, the a value then can act as a substitute of x based on the table given. Remember, the method is only viable if only the denumerator is similar to the 5 statements given. However, we'll be using the first one instead of the fifth one as it is easier to solve later. Now, if we compare the denumerator of our equation to the first statement found in the table, we can... Next up, we let x equal to a sine theta. We substitute the a with 4. Then we move 4 over to x to get x over 4 equal to sine theta, and we arrange it as so. Therefore, theta can be the inverse sine of x over 4. Also, we let dx equals to a cos theta d theta. We can obtain this from a simple differentiation of x equals to a sine theta as shown here. Notice that sine theta equals to x over 4 can be used in the Pythagoras rule, which 4 corresponds to the hypotenuse and x to the opposite of a right-angled triangle. Therefore, we can assume the adjacent of the triangle to be the denumerator of the equation, which is the square root of 16 minus x squared. We can also conclude that cos theta equals to the adjacent over hypotenuse, or 4 over the square root of 16 minus x squared. We then arrive to the equation itself. First off, we should substitute the equation that we find into the main equation like so. Then, we square the 4 sine theta to get 16 sine squared theta. We factor out the 16 and square root the denumerator. Then, based on Pythagorean identities, we find that 1 minus sine squared theta to be cos squared theta. We should square root the cos squared theta to get 4 cos theta. These eventually cancel out. We're left with the integral of 16 sine squared theta in respect to theta. The 16 is moved out, and based on the double angle formula, the sine squared theta is replaced with half of 1 minus cos 2 theta. Again, we should move any factors out of the integral. Then we can finally integrate the equation to obtain 8 open bracket theta minus half of sine 2 theta close bracket plus c. Throw in the 8, and by using double angle formula, substitute sine 2 theta with 2 sine theta cos theta. After that, we should substitute the remaining items with the equations obtained earlier. Then, we should finish off the remaining calculation and finally complete the problem. Thank you for tuning in.